Welcome back to Troubleshooting Agile. Hi there, Jeff. Wait a minute. Jeffrey's not here. We have somebody else here. It's Krunal. Hello, Krunal.
Hello, Douglas. How are you doing today?
I'm doing great and very happy to speak to you, although our listeners are probably confused. They don't know who you are. So, Krunal, you're going to talk to us today about Agile in hardware development environments where people are building physical stuff. And that's a place where I think you have some really interesting stories. Krunal, can you just give us a brief intro to you?
I am a technical program manager specializing in hardware product development. I have worked across semiconductor, automotive, and consumer electronics industries. Worked on some programs and products which has impacted in the scale of billions. And today I am excited to discuss about how we navigate agile principles in complex physical product environments like automotive.
Fantastic. And Krunal, before we got started, you were telling me that you had a very interesting example recently, and I'd like to focus on that example so our listeners can see how these principles can apply to them, whether they're in hardware or software or something else. And your example had to do with a car someone was building that had a really nifty hardware feature, and you helped that manufacturer to get the car to market with that nifty feature much faster. Can you tell us about what the feature is and how you helped the company?
Yeah, so one of the problem which I worked on was enabling a car with a, a feature called passive entry, where if a person walk to the car door automatically opens using a key fob.
Wow. So I have the key fob in my pocket, and I don't have to push any buttons or do anything. The door just opens, and for example, I can put the groceries down or my child down or something like that in the car. I don't have to mess around with the handle. Am I understanding right?
Yes, absolutely. No hands to open the car. Just walk by and car door automatically opens. Yeah.
That sounds super. I really need that, especially because I usually have a wiggly dog on the end of a lead, and messing with her and the door handle is difficult. So this sounds like a really useful feature, Kunal. And you typically, because there are all kinds of safety factors and approvals and regulations and all kinds of things, that would usually take you many years to get to market, right?
Yeah, absolutely. So typically, within a like automotive industry, the product development life cycle varies, and it like for any new product or new technology to bring to market, it may take like typically 2 to 3 years. But yeah, using agile product development methodologies, I was able to shorten that time frame significantly uh, to bring to market within a less than 1 year time frame.
Wow. Okay, that sounds great, especially because I need this feature on my car. Good. So, Krunal, what did you do? So, I don't think you skipped any steps, if I understand right. So, you still did all the regulatory rule checking. You checked on all the suppliers. You made sure that the product was well tested. But I'm guessing that you did more things in parallel, or you did them in a simpler way. What actually did you streamline?
Yeah, I actually followed all the steps, but some of like I basically identified like the entire end-to-end process. So typically in automotive, we go through the waterfall product development life cycle, which means that we go through product design, product development, product validation, and then eventually setting up the manufacturing line and eventually allowing to scale to a high volume manufacturing, right? So uh, and there is a regulation portion involved during the validation where we go through a thorough quality and reliability testing at the same time, uh, ensuring the safety requirements are far meeting the standards and even the compliance and regulatory requirements of any particular region or country are met.
Because this might sound to some of our listeners like a relatively minor feature. It'd be very exciting for me, but it's got some significant safety elements to it. For instance, if some bad person can walk by with a faked fob and get into your car, that's really bad and could be really dangerous for people. So there's huge safety and regulatory and other sorts of barriers in your way. How did you get around them?
Specifically, in terms of safety feature, there was one particular new first of a kind technology that was being deployed, which enhanced the safety feature particularly. But besides that, in terms of the quality and reliability requirements, so we ensured the all the safety requirements and like electromagnetic compatibility and some of the other testing requirements for the key fobs and even the company specific North America, Europe, all the other region safety requirements were met. And I would like to have like a analogy of a key fob is basically a 3D hardware device which can be think of like a PCB with electronics. There are hundreds of components of electrical components on it with an enclosure with many different parts. And there is a firmware and software element of it which can which communicates directly to the car, the security system, and which allows the door to automatically open. So this is how it fundamentally works.
Got it. So it's kind of like a small mobile phone. It's got a case. It's got a chip inside or many chips that do the software. It's got some kind of radio or some kind of communication that sends messages out, and it's got various buttons and things you can control. So have I got the right picture of what's inside the fob that I've probably never looked at?
Yeah, that's an accurate picture. So a modern key fob typically contains this microcontroller, RF receiver for communication, or a chip, which obviously commonly we can find online as well, like the Bluetooth Low Energy and some of the new technologies for precision localization and various electro mechanical components like buttons, all integrated into a compact physical enclosure.
Fantastic. And how do we make one of those fast? Because it sounds like you found some way not to speed up the safety part, but to speed up producing the fob and producing the tests that would allow you to find out whether this was actually a workable feature.
So we make key fob reliable through a combination of systematic design validation, going through a rigorous manufacturing quality control and data-driven iteration, ensuring every component meets the strict performance and safety standards. So starting with the initial proof of concept and feasibility, where we really prove that very first of a new kind technology, which is never there in the market, is thoroughly validated on very small chip. Is it working perfectly or not? And do we have even a, a right path in order to commit to our resources and investment moving forward or not?
So this sounds great for making sure that it actually works, but it also sounds very slow. Where's the fast part?
So yeah, like typically in automotive industry, the product design, development, and product validation. So these three are three independent steps, but at the same time, there is a less element of safety and regulation and risk involved. So these are the areas where if we manage risk and do some of these concurrent parallel path execution, that can significantly improve the frame, and at the same time we are able to identify the risk which we typically know later stage in the product development life cycle early on. So for example, during the initial prototyping, we used 3D in-house 3D printing to come up with an initial design of enclosure. Then we had a local suppliers along with core PCB engineering team. We and came up with that initial prototyping fast to identify whether the enclosure fit is working perfectly or not. PCB, even we didn't worry about the perfect PCB enclosure design, but yeah, we wanted to make sure that the right risk are identified early on. At the same time, supplier engagement typically happens after the product design phase, right? So even like while we were not thoroughly ready with our product design, we started engaging with the supplier. We shared RFQ, shared initial versions of design, came up with the initial plan and that scalability plan. Uh, so yeah, some of those steps were done very early on in order to uh, improve the speed of execution.
Krunal, this sounds fascinating to me because one of the things we're always going on about on the podcast and everywhere is how vital it is to get your customers involved and the people who are participating in your product marketplace and your product environment early in the process. So, what you don't want to do when you're building software is build a whole design and a complex set of sophisticated algorithms and get those all committed and working and tested, and then go ask a user, is this actually useful? That's not a good idea because you don't usually have a very positive answer on that. You want to get prototypes and simple versions and bits that will get you feedback early. And you want that, for example, I would think in the automotive world from your suppliers. Your suppliers might say, oh, yes, I can't give you this many volts. I can't give you something at this form factor, at this size. It won't fit inside the case because we need to have this many capacitors and this many of this and this many of that. I've certainly seen that with some of my hardware clients where they benefit a lot from talking to the suppliers early. I think you're telling us that the standard in the automotive industry is to design the whole thing and then ask whether someone can build it. Is that right?
Yeah, like just basically trying to find which of the steps can be done as soon as possible in parallel. Although, and yeah, and basically we have to assess what kind of risk are we going into. Uh, uh, if like the initial the supplier selection part, like having the once we completed the initial 3D prototyping and PCB part clear at the same time while having that same set of units design released to and bomb released to the supplier and then getting those initial prototypes help at the same time
Bomb is not an explosive thing, by the way, for listeners who might not know. It's bill of materials. It's the stuff that goes in the box. Keep going.
right, right. Yeah, the bill of materials. So, yeah, we release the initial bill of materials to the suppliers so that they can come up with those initial prototypes in parallel because while we are doing the pro development, we also have to ensure the supplier are scaling at the same speed as we internally are for the pro development.
For sure. And I bet you might have had, I don't, did this happen to you? Did any suppliers say, hey, wait a minute, we don't have that many capacitors? Oh, hang on a second, this is going to be too big to fit in the enclosure that you've designed here. Did you have any of that early feedback that changed what you did?
Yeah, so the very first and second prototype we try to do and complete that portion as early as in the process. So our design was almost 70 to 80% already there in terms of initial we already cleared the design for manufacturing and some of those aspects. And yeah, like basically we identified some of those risks early on through multiple iteration of prototyping in-house in a very short time frame because this small like 3D printing and some of those tools which are not I mean like it might be common now but 6, 7 years those on at production scale those were not typically used so we did those stuff pretty manually early on and while we released the files to manufacturing uh, yeah, we gone through some rounds of design reviews for design of like manufacturing, like DFX reviews, so that allowed to minimize some of those churn later on. And
So you didn't have to change what was inside the box late in the process when you found out that there weren't enough capacitors or it wouldn't fit. You were able to change it early in the process, and that meant you went back to design and said, hey, you got to make it 3 micrometers shorter or something like that. Is that right?
yeah, we made sure the interference and some of the common technical issues which we expect after releasing to the supplier, we try to minimize those early on. So when it goes to the supplier, we just
Fantastic.
focused on the areas which were related to the next step, which is scaling from 5 units to 50 units using a soft tooling. Um,
Now you got to tell me about soft tooling. What is soft tooling? That sounds fascinating and really important to some of our listeners.
So soft tooling typically refers to a rapid, lower cost manufacturing tools used after a post R&D environment, uh, like for low volume production, typically made from less durable materials or through additive process like 3D printing um, or even injection molding, allowing for quick design iteration before committing to a very hard tooling, which is made of sophisticated equipments and yeah, even like certain materials which requires a big investment and cannot be changed later on, but typically useful for scaling to from 100 units to 10,000 units eventually.
Amazing. So I thought soft meant soft as in software, but you mean soft as in actually physically soft. It's more flexible, it's more brittle. Maybe it breaks more, or it's less durable, but you want to make the initial fob out of plastic, say, or even I could imagine out of wood or something. And that's enough for you to then manufacture a few doors, walk past them a whole bunch of times, check out whether it fits in your pocket, whether there's too much interference, whether the components will fit. And then you make it hard, i.e., physically hard, by making the fob out of more expensive metal or something like that. Am I understanding right?
Yeah, that's an excellent point about iterative nature of this physical prototyping. Even before soft tooling, we go through this like the design for manufacturing and like the virtual build and virtual analysis, where we have this like the design in 3D CAD model, and we go like try to have all the simulation, how it will function in like real world before even going through the soft tooling. Once that we pass that initial virtual analysis phase, then we commit to a soft tooling because there is some investment involved, but not as much as a large tooling. I mean hard tooling.
There we go. And of course, that kind of soft tooling has analogies in software, but really the earlier part, the trying it out in a virtual environment, is closer to what people do in software, where they actually roll out to a small number of users, or they'll have focus groups, or they'll have clickable prototypes, or all kinds of different tricks that allow them to find out whether the software is functioning right before they give it to thousands or millions of users. You're doing an extra step in there, which I think we should be thinking about in the software world as well. How do you get something that is cheap to manufacture, not as durable, not as high quality, but it gives you lots and lots of feedback? I've got a client in Africa right now who is trying out some of this. They're building what we call in the software world walking skeletons. So they'll build something that goes all the way through from, say, a person applying for a loan all the way through approval of the loan. But they don't do every single step. They don't do everything in depth. They do all kinds of steps along the way, but in a briefer and simpler and not really robust way. But they aren't going to make very many loans that way. They're going to make a small number, and they're going to check out, does this work? And they're going to find all kinds of problems in the steps, and that's cheaper to produce and less scalable, but gives them lots of feedback and learning early. Then they're going to harden that into a full skeleton, not just the bones, but also the muscles and the skin and everything else, all the bits that go on top, so that they can actually stabilize it for lots and lots of loans and lots of customers. So I think there's a lot for us in software to learn from our hardware friends, doing this kind of intermediate step between, did I test it internally and did I make millions of them? Because it's so easy in software, as you know, Krunal, to make millions of copies of something. And it's so easy for us that we forget that step in between, the soft tooling step. So I think that's going to be really interesting to all our listeners, both software and hardware. Really fascinating, Krunal.
I completely agree because specifically while in software and we can deploy continuously, right? And hardware iteration involves like some physical builds with months long lead time and at the same time significant capital investment. Uh, so that portion is slightly different, and then the walking skeleton strategies is always our way, mirroring software fast feedback loops by segmenting risk and delaying some of these irreversible like commitments until like all the critical or uncertainties are resolved like early on. Because in hardware there is a high degree of ambiguity early on in the process during the concept and feasibility and pro design phase, which ambiguity cost reduces, and there is a cost curve associated with, which means that uh, initially there is almost zero or like minimum cost of failure. But as we gradually proceed from concept and feasibility to product design to soft tooling, uh, so there is the point which we reach uh, where we commit to like a hard tooling and eventually scaling to a high volume production. And this is very critical, especially if we are like doing a concurrent engineering and parallel path to squeeze the timeline, right? But this point really matters because we are committing to a big investment value at that stage. And if we are not doing that element very perfectly, then we are exposing ourselves to a risk in terms of, yeah, like which may cost us like millions.
And that's, I think, a very good final point, which we can take in software, hardware, and everywhere else. If you don't compress this kind of information gathering, learning early on, if you don't do more things in parallel, if you don't learn quickly, then you're doomed either to hit hard tooling too fast, and I can't count the number of clients for whom that's happened on both hardware and software, that they, oh my God, wait, we have 100 units, we have 1,000 units, we have 1,000,000 units, and they're wrong. We just discovered it. Oh no, I only wish we'd known sooner. So if you want to avoid that kind of sad outcome, it's very important to make sure that you compress the early stages and therefore increase the learning early. And Krunal, you've managed to get the time down by 3 to 5 times, which is a really fantastic result. Look, listeners, if you're interested in hearing more from Krunal or talking more about hardware, or if you disagree with me and Krunal and you think, hey, wait a minute, soft tooling is a dumb idea, you should go right to hard tooling, waterfall is a great solution. We're always interested in people who disagree with us because that maximizes our learning. So the best way to get in touch with us and ask those kinds of questions is on agileconversations.com. That's where you'll find our book, Agile Conversations, and material on speeding up your process in lots of different ways, all free, videos and conversational dojo kits and all kinds of other things, plus lots of different ways to get in touch with us. Krunal wrote me an email. There's Instagram and I don't know, Twitter or whatever it's called this week, and probably lots of other ways. And we like hearing from you on all of those channels. So get in touch with us one or another way. We really like hearing from our listeners, and Krunal is an example of someone we really wanted to talk to, and here he is. Krunal, tell listeners, how could they get in touch with you? So if they wanted to hear more or read some of the things you've written, where would they go to do that?
So yeah, you can connect me on LinkedIn. I'll share that link in the along with you, and then I'll share the
I'll put it in
portfolio.
the show notes. Don't worry. Yep. So LinkedIn is the best way, Krunal?
Yes.
Excellent. We'll point people to your LinkedIn, no problem. And of course, the other way to keep in touch with the Troubleshooting Agile folks is by coming back again next week when we'll have another edition of Troubleshooting Agile. Thanks, Krunal.
Thank you so much, Douglas, for having me. Have a wonderful day ahead.